in solving quadratic equation. This general method was established by this Arabian mathematician, and it is a method that can solve any form of quadratic equation, and this method is actually the method that was used to establish the general formula that we are familiar with. So we are going to use this method, explain this method, and use this method to establish the quadratic formula. Now, follow along. We are given the general representation of quadratic equation to be, let's move this, to be as squared plus bs plus c equals 0. This is the general representation of quadratic equation. Then let's assume that we want to use the method called the completing the square method. Completing the square method. I'm going to tell you the steps that are used when you are using this method now. So pay attention to it. If you are to use completing the square method to solve any quadratic equation, there are some steps that you have to follow. The first step is that make sure that the coefficient of the highest power, which is s squared in this place, is 1. It is not minus 1. Even if that means if you have minus 1 as a coefficient, you have to divide it so that the coefficient will be 1. So in this case, we have our coefficient to be a, divide every entity with a. That's the first step. So that means we have s squared plus b over a s plus c over a equals 0. This implies. That's the first step. Make sure that the coefficient of the variable with the highest power is 1. So the second step that we move to is that we should take the constant entity, take it to the other side. That means that we have s squared plus b over ax equals to minus c over a. That's the second step that we are using. That's the second step. Then the third step is that we should find a way, we should add to both sides a perfect square that will be gotten from, okay, if I implement that, you will get it better. Let me just say the theory. What I mean is that we are going to find a way to get the perfect square so that we will add the perfect square to both sides of the equation. How do you mean perfect square? For us to get the perfect square, we will go to the sum side, that is the coefficient that is standing with this variable with the lowest power. We are going to say, take the coefficient out, multiply it with half, then square it. This will give us a perfect square that we are looking for. Then that means we can add this one to b over 2a squared. So we have gotten the perfect square. Anytime you are looking for the perfect square, multiply the coefficient of this lowest variable x with what, half, then square it. This approach that I'm using was explained by that Arabian mathematician. So you square it now. Then when you square it, you add it to both sides of the equation. You add it to this side, you add it to this side. What I mean is that this one will now mean s plus b over 2a squared. Then it's now equals to minus c over a plus b squared all over 4a squared. You multiply this one out. Anytime if you are adding the perfect square to both sides of the equation, you observe that this one has square, this one has square. You are replacing all of this. You are replacing all of this with b over as with the coefficient, as in the perfect square that you got in here, and you are putting the square outside of the two. Actually, we are looking for our s. So we don't want s to be repeated here. So we ignore this s. Okay. So in that case, we are left with this. So let's try and bring it together. Let's try and make this one a single fraction. So this is 4a squared. We are looking for s. We are to make s the subject. So this is 4a squared. This is going to be minus 4ac A cancel A, then we have 4A, multiply that with minus C. Then plus 4A squared cancel 4A squared, this is B squared. According to this, then we have S plus B over 2A squared implies. So we move to the next side. So we have S plus B over 2A, everything is squared. Then we have B squared minus 4AC, rearranging this all over 4A squared. So what do we do now? For us to find S, make it the subject, we take the square root of both sides. So that is S plus B over 2A equals to square root of B squared minus 4AC all over square root of 4A squared. Then we have S plus B over 2A. This remains like that, B squared minus 4AC. Find the square root of 4, and that is 2. Find the square root of this, that is A. We dealt with this explanation in our indices. You can check our previous lectures to understand that. So this looks like the establishment of the general formula. Yes, actually it was completing the square method that established the general formula. So finally, making S the subject is the square root of B squared minus 4AC all over 2A minus B over what? 2A. They are not done because we still have this fraction. Then we can say 2A square root of what? B squared minus 4AC, then minus what? B. So finally, we can say our S is equals to, we can rearrange this is minus B. The square root can produce two answers. If we are looking for square root of any number, any positive number now, because we are looking for square root of negative number, that one is going to give us a complex number. We are not dealing with that. If you are looking for square root of any positive number, it must always give you plus and minus. What I mean is that if you are looking for square root of 9, for instance, plus 3 times plus 3 will give you 9. Minus 3 times minus 3 will give you 9. That is why the square root here, we have to put plus and minus in it. The reason why we are putting that plus and minus is because we need those two answers for quadratic equation. We need two answers. So we need the case of applying the concept of when you find the square root of numbers, it can be both positive and both negative. So this is B squared minus 4AC, everything on 2A. This is what we call the general formula. Or in our layman language, we also call it the almighty formula. But we prefer calling it the general formula. So solving for our S, using completing the square method, is equals to minus B, plus or minus, square root of B squared minus 4AC all over 2A. And this is the formula that we use in solving any question. So the step that we established in completing the square method is just the step that we use in solving any quadratic equation. So we're going to consider some examples to bring this theory into practical. Let's move on.